How rocket engines are built using AI. In the 1990s, NASA spent over $1.3 billion on a dream. They wanted a spacecraft that could reach orbit in a single stage. No dropping boosters in the ocean, no complicated staging. To do it, they needed the holy grail of propulsion, the Aerospike engine. Most rockets use a bell-shaped nozzle. It's efficient at one specific altitude, but as the rocket climbs, that efficiency drops. An Aerospike, however, automatically adjusts to the air pressure around it. It is the perfect engine, but NASA's program was canceled. The tech was too complex. The costs were too high. The Aerospike became Aerospace's favorite what-if. Fast forward to today. A company with only 2 employees, Leap 71, just built and successfully tested their own Aerospike. They didn't spend a decade. They didn't spend billions. They did it in weeks. This isn't just a fluke. In under 2 years, Leap 71 has designed and tested 9 different rocket engines. These aren't plastic models or digital simulations. These are real, metal-printed engines running on methalox, the same high-energy propellant SpaceX uses for Starship. During a recent test, their bell nozzle hit 93% combustion efficiency on its very first try. In traditional aerospace, hitting that number usually requires years of trial, error, and exploded hardware. How is a 2-person team outperforming massive government agencies and billionaire-backed corporations? They didn't just build a better engine. They threw out the entire design process and replaced it with something called Neuron. When we hear AI today, we think of large language models like ChatGPT or image generators like Midjourney. These are generative AI. They work on patterns. They guess the next word or the next pixel based on a massive database. If you ask a generative AI to design a rocket engine, it might give you something that looks like a rocket, but it will likely explode. Why? Because generative AI can hallucinate. It doesn't understand physics. It only understands what rocket-shaped things look like. Leap 71 is doing something fundamentally different. They use computational engineering. Neuron, the model they built, isn't a neural network. It's a synthesis of physics, manufacturing constraints, and logic encoded into software. It doesn't guess. It calculates. Here is why this matters for the future of technology. Neuron is deterministic. If you ask a standard AI why it made a specific choice, it often can't tell you. It's a black box. But with Leap 71's approach, every single manifold, every cooling channel, and every bolt placement is traceable. Every design decision lives in reviewable code. If a wall is 3 millimeters thick, the code can tell you exactly which thermal stress law required that thickness. It is entirely auditable. For leaders and engineers worried about AI governance and safety, this is the blueprint. It's an AI that doesn't just work. It's an AI that can be interrogated and verified. Traditionally, designing a rocket engine takes months of manual drafting in CAD software. If you want to change one small variable, you might have to redraw half the engine. With Neuron, the engineers don't draw the engine. They write the rules for the engine. They input the thrust requirements, the fuel type, and the physical limits of the 3D printer. Then, they hit Generate. The computer produces a final, manufacture-ready file in minutes. This allowed Leap 71 to go from a blank sheet of paper to a physical, 3D, printed engine ready for the test stand in a fraction of the time it takes a traditional firm to finish a preliminary review. We are entering an era where the size of your workforce no longer determines the scale of your achievement. Leap 71 has proven that 2 people, armed with the right computational model, can solve problems that stopped NASA in its tracks 30 years ago. They've moved the holy grail of rocketry from the history books back onto the launch pad. The headline isn't just that we have a new Aerospike engine. The headline is that we have a new way of building the future. One where physics is the language, code is the architect, and the black box is finally open.